In this lesson, we're going to look at one of the distinguishing features of an object-oriented language. This is the feature called inheritance. Let's start by taking a look at an example. This is the zoo project. Notice here is the main class of the zoo project. We come into the main method here, and the first thing this does is to create an instance of the class that it's a member of, this zoo class. You'll see that in the zoo class we have three variables, a sheep, a lion, and a zebra. We create instances of those, and that allows us to visit the zoo, where visiting the zoo prints out the message, you visit the zoo, and then prints out a series of messages as you interact with these animals. So we can feed the sheep, we can pet the sheep, we can feed the lion, which might be a little dangerous, we can pet the lion, which might be really dangerous, and we can similarly attempt to feed and pet the zebra. Let's take a look at the definitions of those classes. The zebra here says public void feed and just prints out a message that says what the zebra does when we do that, and it has a pet method. Similarly, the lion has a feed method and a pet method. It behaves slightly differently, and it's not a terribly good idea to go petting it. And similarly, the sheep, we can feed it and we can pet it. This is obviously one of those sheep that you find in the children's petting zoo because it's perfectly willing to be petted and thinks that you should give it more attention. Let's run this code and take a look at what happens. So there's the body of where things are going to get interesting. And we can see you visit the zoo, you go to see the sheep, you try to feed it, sheep eats grass, munching happily. You try to pet the sheep, sheep pushes against your leg. So everything pretty much behaves as we would have expected it to. But notice how each animal has quite a bit in common. You can attempt to pet them, even in the unwise situation, and you can attempt to feed them. At a philosophical level, we can make a generalization about these creatures. They are all animals. Now, object-oriented languages allow us to express this generalization in the way we create our classes. So let's create a class that describes this generalization. We're going to call this class an animal. So I'm going to right-click on the zoo animals package, and I will say create new Java class, and I will call it animal. Now in the animal class, I'm going to put the same basic structure. We have a feed method, says the animal eats, and a pet method that says the animal gets petted. Now we can also make modifications to each of our three animal classes. Our zebra, we're going to say this extends animal. And for each of these methods, we're going to add the label @override. I'm going to do that for all three classes. Lion extends animal and @override and @override, and similarly sheep extends animal @override @override. Save all of those. Now what we've done is we've created a relationship. We are saying that, for example, a lion is a specialized form of animal. Now there's a lot of terminology you might come across here. We might say that animal is the generalization of lion, that animal is the parent class of lion, that animal is the base class of lion, or even that animal is the superclass of lion. Similarly, we might say that a lion is a child class, a derived class, a subclass, or a specialization of lion. Unfortunately, there's a lot of interchangeable terms to choose among. One important note here is that Java, like many but not all object-oriented languages, insists that there can only be one direct generalization for any one specialized class. That means you can extend one other class, although that class might in its turn extend something else. This is called single inheritance. Don't worry about it too much, but just know that our lion cannot extend both animal and carnivore classes, for example. Let's think again about this @override label. That tells the compiler that we intend that this method should replace an existing one in our parent class. That is, the class that we extend. This replacement process is called method overriding. It only works if the method's name and the type and sequence of method arguments is identical. The return type must be the same too. There are some other rules, but this is not the place to get tangled up in them. So let's see what this code does. Everything is saved, and we'll go to our Zoo Java class and we'll run this. So it basically behaves exactly the same as it did before. Our sheep eats grass and munches happily and pushes against our leg and so forth. Let's just verify that we really did have behavior that we inherited into, say, the zebra from the animal before we did this override. Let's do this. We'll take this block and we will comment it all out. We'll save that. Notice there's no errors in here. There's no errors anywhere. Now when we run it, you'll see that we have the interaction with the sheep and we have the interactions with the lion. But then when we go to see the zebra, we try to feed it, it says animal eats and animal gets petted. So we really did get this behavior inherited into the zebra class for free. In our case, however, we actually don't want to inherit that original behavior. We do specifically want to replace it with behavior that is specific to a zebra. So we'll go back to that version of it, save the file, and now so far this just seems like a syntactic curiosity which might save us from cutting and pasting some code from time to time. But actually we can do quite a lot more with this. Let's take a look at something we can do. We're going to switch into the original zoo class, and here where you see we have the private variables for the sheep, the lion, and the zebra, I'm actually going to create a new form of this. I'm going to say private animal array animals, and I'm going to initialize it with the sheep, the lion, and the zebra. Now it's complaining about the animal because it doesn't know what that is, but if I click on here, we can add the import for zoo animals. Now the other thing that I can do is that now that I have an array of animals, I can actually iterate over that array. So in effect, these two pieces are essentially equivalent. I have this version which works with the individual variables here, and this version which is working with the array of animals. And if I save that and run it, notice that if I double click on here, I can make this window a little bigger. First of all, we go through, we visit the zoo, we work on the individual variables, and then after we have attempted to feed the zebra the first time, or pet the zebra I think actually, we then come down and this is the output from the second part. It says we try to feed the animal. Sheep eats grass, munching happily. Try to pet the animal. Sheep pushes against your leg. So let's go back to the source code. You'll see that's where this is coming from. We're iterating over this array of animals and calling feed and calling pet methods on them. Now there's something important going on here. Although the compiler sees us invoking methods feed and pet on an animal object, the behavior we see is the behavior of the actual animals, lion, zebra, and sheep. This is important. What we get is the behavior of the actual object at runtime, not the behavior that the compiler might have expected from doing a static analysis of the source code. This is called dynamic invocation or late binding. It's a critical feature of method overriding that's going on here. Notice that we are effectively able to substitute our derived classes, lion, sheep, zebra, for the generalized class animal. We did this and used an array of animal to hold the individual animals, and we can do this with method arguments too. Notice that I can create a special method, and this one says visit animal, and it takes an animal as an argument. Now, in my loop here, I can replace this lot with a simple call to visit animals for animal I. Just to clarify this code a little, I'm going to comment this block out. So now we'll just see the one set of visits that we get when we visit the animals in the array. In fact, having done that, I can comment these variables out because I'm not using them at all now. Save the code and run it. And we should see that we get try to feed the animal, sheep eats grass munching happily. So it's exactly the same as it was before. What we've been able to do is to write a method that works on an animal and then pass in a particular animal, whether it be a sheep, a lion, or a zebra, taken out of that array, and behave accordingly. So this method knows nothing about sheep, lions, or zebras. It only knows about animals, and yet it works perfectly satisfactorily with actual animal implementations. So, in this lesson, we've taken a first look at the inheritance concept and its implementation in Java syntax. With a little luck, you can see that this mechanism can help us create generalized code that is more flexible than it might otherwise be. For example, we could create a tax calculator method that takes a taxpayer as its argument, and that taxpayer could actually be a person or a corporation, and the method works correctly using behavior from the taxpayer itself when necessary to distinguish the particular type of tax is owed.